All right, so here's our agenda. We're going to try and cover 2 sections today. And then next class, on Tuesday, we'll cover 1 remaining section. Then on Thursday of next week, we'll have our review for our first exam, which will be the following Tuesday, which is October 3rd. All right, so this exam is October 3rd. If I don't finish up 5.2 today, then I'll just overlap it into next Tuesday. And everything up through 5.3, everything we've covered up through 5.3 will be on the exam. All right? So when we finish 5.3 on next Tuesday, you'll have a full week before the exam to make sure that you understand all this material. Any questions on the timeline? Okay, let's get down to business then. Last time we were talking about matrices and how we can use matrices to do some word problems and kind of use that shorthand notation to help us make computations faster, especially if we're using a computer or something like Excel. This is a completely different subject, all right? So we're going to kind of switch gears again, and we're going to go back to this idea of a linear equation, but we're going to make one pretty significant change to it, and that's this word inequality. All right, so we're first going to talk about linear inequalities with 2 variables, and then do you remember when we talked about systems of equations? We're then going to do systems of linear inequalities in 2 variables. So let me kind of map out what we've got here, right? Because remember in the beginning of class I told you that the language of what you're looking at is important. All right, so just to recap, a linear equation with 1 variable is going to look like this. 3x plus 4 equals 10. You have an equation, you have 1 variable. It's linear because it's raised to the first power. And when we solve this, what do we usually get? When you actually solve this, what do you get? Just some number, right? It's just going to give you some number. So your answer to this is a number. Okay, let's compare that to a linear inequality with 1 variable. Can't write. So all I'm going to do is I'm going to change this equation symbol to an inequality symbol, right? We still have linear because it's x to the first power. There's 1 variable in there. And when we solve this, what does the answer look like here? Anyone remember? If I say solve this linear inequality in 1 variable, what will your answer look like? Will it be a single number like this? What's that?
2 numbers.
2 numbers, like in maybe everything in between them?
The inequality symbol in the middle.
That's right. Okay. So you get something like, greater or less? Yeah, greater or less, something like that. But you get an interval. You have to look back in your notes. You get an interval, and numerically on a number line, it would look like this. It would be like maybe some number. I'm just going to make this up. This is not the answer. Then everything like bigger than that. Does this look familiar? And then you would say something like 4 to infinity. So there were an infinite number of answers here, right? You all following me? Okay. This one, let me put this one graphically. If I graph this one, you would get a single answer, and it would be that point. That point on the number line is your answer, right? Here, it's that answer, but it's a bunch of other answers too, an infinite number of them. All right? Then we talked about linear equations. Okay, linear equations in 2 variables. And let me give you an example of linear equation in two variables. All right, you have two variables, it's an equation, and you've got linear because they're both to the first power. And the answer to this is what? If I try and visually, what is it?
X is going to equal something and Y is going to equal something?
It's an x and a y that both satisfy this, right? How many x's and y's satisfy this, though?
1.
Well, I could find an x and then a y. Could I find a different x and a different y?
It's a graph.
It's a graph of what, though? It has x and y intercepts. It's a line. This is a line, right? You all right? You okay today? Okay, so look, it's all the points that satisfy this equation. So when we graph it, all those points together form a line, right? So the answer here is a line. All right, so what is today about? The beginning of today. Linear inequalities, two variables. That means we're going to take this, which was a linear equation in two variables, and we're going to replace this with an inequality symbol. We're going to try and figure out what that means and what the answers are. Okay, let me do one more thing before we do that. How about if you have a system of linear equations in two variables? That means you have something like this. 3x plus 4y equals 10, but then also how about like 2x minus 5y equals 6, and you put that brace out there. What does the answer to this look like? What is it geometrically? Do you remember what it is visually? It's where what? It's where two lines intersect each other, right? This, see, because you have two of these, right? If each one of these is a line, then that system is trying to figure out the intersection of two lines. So the graph, you're looking at something like this. Here's one of them. Maybe that's this one. And then you're looking at the other one. You're graphing it. And the solution to this is that point. All right? Point of intersection. Now, do they have to intersect? If you have two lines, do they have to intersect? No. They could be parallel. They could be the same line. But the thing that was most interesting for us was this scenario right here. Okay? So, today is not about one equation stuff. One variable stuff. Today is about these guys right here changing this to an inequality, and these guys right here changing these to inequalities. So that's what these two sections mean. We're going to do linear inequalities in two variables. That's that switch to inequality. Systems of linear inequalities in two variables, switching both of those to inequalities, and talking about what those answers look like, what do they look like visually, right, and how do we write the answers. Understand? Okay. So let's start out with the linear inequalities in two variables. Y'all doing all right? Y'all seem tired. Are y'all tired? You ready for the weekend? Yeah, I know, it feels like it, right? Okay, well, let's just grind through this. So we're going to start out with an example, because I'm hoping with an example you'll be able to see kind of what the answers are going to look like here. Okay, I would like for somebody to give me an x and a y that will satisfy this inequality. Do we all recognize that this is a linear inequality? Two variables. Yes? Okay. So someone give me an example, an x and a y that satisfy that inequality.
Wouldn't you want to give like either x or y by themselves at first?
We might want to do that in a second, but I'm just asking if you can you just like look at this and like mentally just give me an x and a y that work. 3 and 4. Okay, let's try that. 3 and 4. If I try that, I'm going to get 2 times 3 plus 3 times 4. Is that bigger than or equal to 10? Absolutely, that works. Okay, so I'm going to graph that over here. The 0.34. 1, 2, 3. 1, 2, 3, 4. Somebody else? Give me something. 5 and 6. Okay, 5 and 6. 2 times 5 plus 3 times 6. Bigger than 10? We all agree it is? Yes? Okay, 5, 6. 3, 4, 5. Here's 5. Here's 6. Okay. Now, this is where things are different, okay? Because if this wasn't equals, if it was equals, then this would be a line, wouldn't it? And so all I'd have to do right now is connect those with a straight line, right? And that would represent all the answers. Right, somebody give me another point that works here. 7, 8? That might go off my graph, but I'll try it. Okay, 7, 8. Okay, if I do that, 2 times 7 plus 3 times 8, that's obviously bigger than 10, right? That works? Okay, 7, 8 is going to be out here. 6, 7, here's 7, 8, 4, 5, 6, 7, 8. So I'm going to have to come up here. I don't know. Y'all still might think that lives on a line, on that line. 2, 2. I don't know. That still looks like a line, doesn't it? Kind of. That's not what I was going for here. 1 in 10. Would 1 in 10 work? Let's see. 1, 10 would be 2 times 1 plus 3 times 10. Obviously, that's bigger than 10, right? But 110 is over here, isn't it? So the answers to this are not on a line, are they? So what is it then? I mean, because not everything works, right? Let's try this. How about 0, 0? Does that work? 2 times 0 plus 3 times 0. Is that bigger than 10? No, it's not. So this doesn't work, right? So this point right here, I'm going to leave it as an open circle. That is not part of our solutions. So some things work, some things don't. Do y'all see that? But it's not a line. It's not a line. So what is it? Well, I'll tell you how we do it, okay? What it's going to turn out to be is an entire shaded region of that flat plane. All right, so what I mean is it's going to be an entire portion of this plane shaded in, and everything within that shaded region is valid. The question is, where is that shaded region? So here's the standard procedure. This is how we attack this. What we're going to do first is we're going to look at this, okay? And we are going to start, first step, turn it into an equation. Okay, we're going to start by treating it like a line. We're going to forget the inequality completely. Understand? We don't care about this right now. We will have to address it. But right now, we don't care. So we turn it into an equation, and then what we do with this is we graph it. All right? We're going to graph this line. Second step, graph the line. Now, how do you graph this equation? How do you graph a line? You can solve for y. That's one way. Another way is find the x and y-intercepts. Those were the two methods that I shared with y'all, right? You either solve for y and then use your rise over run and y-intercept, or you just find the x and y-intercepts. So what would y'all like to do? Solve for y or do x and y-intercepts? I don't care. You want to do x and y-intercepts? Okay, so if I want to do the x-intercepts on this line, how do I find the x-intercepts of this line? Turn what to 0? Y equal to 0. So you take this equation, you replace y with 0, and you'll get 2x equals 10. I'm sorry, I already wrote the solution down there. 2x equals 10, divide by 2, x is 5. So that means the point 5, 0 is part of this, right? Now to find the y-intercept, you do the same thing except you set x to 0, right? So 2 times 0 plus 3 times y equals 10. That goes away, you get 3y is 10. So you get y is 10 thirds dividing by 3. So y is approximately 3.33, right, repeated. So that point right there looks like this, 0, 3.33 repeated. Now for those of you who don't like this method, you could have solved for y, right? If we solve for y, I'll just show it up here. You would have y equals negative 2 thirds x plus 10 thirds. So you would have moved the x term over, then divided everything by 3, and you would have had this. This would have been your y-intercept. This would have been your rise over run. Okay, either way, you choose. Okay, now the third step. I'm leaving the original problem up here for a reason, all right? The third step is to use a solid line if you have this or this. Use a dashed line if you have this or this. So you have to look back at the original inequality, the original linear inequality. And if you have the equals in here, right, that's the little equals in the inequality, you're going to draw a solid line. If you do not have that, you will draw a dashed line. And we'll talk about what the differences are after we do it. So in this case, am I going to draw a solid or a dashed line?
Solid.
Solid line, because this is got the equals in it. So let me draw my graph over here. And remember what those x and y-intercepts were. Okay, I had an x-intercept, what was it, 5, 0? 5, 0, so 1, 2, 3, 4, 5, here's 5, 5, 0. And then I had a y-intercept of 0 and then 3.333, right? So 1, 2, 3, here's 4. So 3.3 is about right here. And now I'm going to connect those two with a solid line. And that line goes forever. Okay, so what I told you was that the solution to this is not a line, right? I said it's an entire like shaded region of the flat plane. And what that line is where it cuts the region, okay? So our region is either going to be all the stuff up here, forever, out forever, or it's going to be all the stuff below it. It's one or the other, all right? One or the other. Now, I know some of you in high school are taught a way of doing it where you look at this symbol and that somehow tells you above or below. If that's the way you were taught, I don't recommend you do that, all right? It's dangerous. It's very dangerous. The proper way to do it, the safe way to do it, is to do one last step, and which is to test a point. All right? So what we're going to do now, step 4, is we're going to test any point not on the line. And what I mean by that is this. I know that it's either everything above it or everything below it. It's got to be one or the other. So what I'm going to do is I'm going to pick a point right now that's not on this line, and I'm going to check that point into the original problem. If it turns out to be true, then that point is part of our solution. If that point does not turn out to be true, then it's not part of our solution. So let's try a point. Now, what is any point that doesn't live on this line? 1, 4? 1, 4? Is that what you said? So 1 and then up 4, that point would not live on our line. Agreed? We could use that. Someone give me another point. 2, 7. 2 and 7 would work. 0 and 0, right? 0, 0? Wow, 0, 0 is a nice one, isn't it? Because that's easy to plug in. Now you could pick any number you want, or any point you want, as long as it doesn't live on the line. 0, 0 is the one we always want to try and see. That's the one we prefer to check, because it's easy to check. The only time you would not use 0, 0 is if what? If your line actually went through 0, 0. Then you can't use it. But in this case, I can, right? So I'm going to check 0, 0. Even though I could have done 1, 4 or 2, 7, all right? I'm going to go 0, 0. Pardon?
You can do negatives, right?
You can do anything, yeah, any number you want. Just make sure it doesn't lie on that line. And that you can always tell by just visually looking. Just be safe. Pick something far away. All right, so when I say I'm going to test this, what do I mean by test it? Plug it into this, right? To this, not to where we change it to an equals. Go back to the original inequality and plug in 0, and you get 2 times 0 plus 3 times 0. Is that bigger than or equal to 10? Is 0 bigger than or equal to 10? No, not today. All right, so that is not true. What does that mean? This point is not part of our answers.
So you shaded it.
So I'm going to do everything on the other side. All right? So I'm going to shade the top in this case. And when I shade it, I'm just going to do this. Now there's another way to, do y'all understand that this line extends forever and it's shaded? Extends forever and it's shaded, right? So there are an infinite number of answers. Yes?
That would be anything positive?
There are some negatives. Look, I mean, you can have like -2 and +10. That point works, right? You agree? Yeah. So now what we can be sure of is that both the x and y aren't negative, right? Because look, if we try and go, oh, well, let's see. Anything here? Anything down here? Will anything in here work? Doesn't look like it, right? Because this line is always above, right? So you don't have to worry. Like, there's no way to ever get a point in here. All right, so this is okay? This is the way we write our answers. Our answers for linear inequalities in 2 variables, our answers are pictures. There's no like interval notation or anything like that. It is that picture. So that's what you're going to be asked to draw on a test. Now there's another notation we can use instead of drawing all this shading. And I'm going to show it to you because when we get to the next topic, which is systems of linear inequalities, you need to know this will help you trying to find the answers. What we can do is we can draw our solid line, and then we can draw little arrows like this. And imagine if this wasn't here. Wouldn't that be enough to let you know that it's this line and everything up here? Yes? Okay, so this is acceptable, or with the lines the way I shaded it. Either way. Okay? All right, so I'm gonna change the problem. We're gonna do a different example. And all I'm gonna do now is I'm going to change that symbol right there, and I'll do it in a different color so that you know I'm doing a different problem. I'm gonna change it to that symbol. All right, so let's see if we can go through this 4-step process. So what, if you're trying to, that last step where you tested the point, can you tell me in words, tell me in words what you're doing? You're taking a point and doing what with it? In step 4, you're taking that point and you're testing it, so that means you're plugging it into the original, and then what?
See if it's not on the line.
So if it's true, if it comes out to be true, you're going to do what? Shade everything on that side of the line where that point was, right? If it's false, you go to the other side of the line. All right? Okay, so how about this? What changes in this problem? I mean, does the first step change? No. First step, you still turn it into an equation. Right? So that would be exactly the same. I would get the same X-intercepts. I'd get the same Y-intercepts, wouldn't I? So I already did this work. I know it's 5, 0. That's my X-intercept. And I know 0, 3.33. That's my Y-intercept. So that didn't change. Step 2 is to what? Graph it. But for step 2 in the graphing, oh wait, was step 2? Step 2 is graph?
Yeah.
Okay. Step 2 and 3, you should probably be thinking about at the same time.
So it's either equal to the
1, 2, 3, 4, 5. Here's 5. Here's a point. 1, 2, 3, 4, 5. Let's see. 1, 2, 3. 3.3 was here. So the difference now is that when I do this, I'm going to do what? I'm going to use a dashed line. And the dashed line is because that doesn't have the equals on it. So I draw a dashed line through here. Like this. And then I'm going to test a point. So what point do you want to test?
0, 0.
Let's go with 0, 0 again, right? It's there. So let's plug in 0, 0 and let's see if this works. I'm ready to step 2 and 3. We're here. So step 4 is the test point. I'm going to test 0, 0. And when I plug that in, I get 2 times 0 plus 3 times 0 is less than 10, right? And that means 0 is less than 10. Is that true? Yes, 0 is less than 10. That means this point right here is part of our answers. So you have to shade down. So I'm going to do it 2 ways. I'm going to do it with the arrows like this. I could do that. Or I could just shade the whole thing in, right? Just do this thing. Whichever you want. What is the difference? Can anybody tell me what the difference between the solid and the dashed means? Like, what does it mean? Why is it important for us to do dashed or solid?
The inequality doesn't equal
It goes right up to it, but doesn't include the line. What does that mean, though? Like, if I try and pick a point that lies on this line right now, will it work? If I pick a point on that line, will it work? No, it will not. Okay? So that's what the dashed line means. It's still like a boundary, but you cannot take points on that boundary. It will not satisfy that inequality. When we had the solid line, that meant if you pick a point on that line, it will satisfy the inequality. That's the difference between the dashed and the solid. Understand? Okay. All right, so let's try and do a word problem that would somehow give you some value to this sort of thing. Let's go back to the iPhones. Y'all love the iPhones, right? Do y'all not love the iPhones? Every time I say that, y'all don't seem to react. Do y'all like Androids? Okay, so you have to have that same enthusiasm for your iPhones then, all right? All right, last class we were talking about 2 different versions of iPhones, right? Do you remember what we were doing? We had the iPhone 8 and then the iPhone X. Remember that? And we said that the retail price, and we were making it up, right? Retail price, do y'all have that in your notes? What did we say for the retail price for these? 800 for this one?
Yeah, and you said 1,000.
1,000 for this one. All right. Got it? Remember that from last class? Yeah? Okay. So I'm one of these big executives at iPhone or at Apple, and I'm trying to figure out how much money we want to make, right? And I come up with this question. How many eights. I'm just going to call it 8s and X's. Is that all right with you? How many iPhone 8s, how many iPhone X's must we sell to make a revenue, or to have a revenue? I was going to say make a profit, but it's not profit, just the money coming in. To have a revenue of $345 million. Okay? I want to know if we can bring in that amount of money. And if so, what is it going to require? How many of these are we going to have to sell? Maybe I should add something into this. A revenue of, let's add into this, at least. Because I don't care if we make more. That's kind of important that I put that in there. So I wonder if any of you see that this is actually a linear equation, a linear inequality in two variables. Okay, help me set it up. How is this a linear inequality in two variables?
You got your two iPhones.
We have our two iPhones, right?
And then the at least means the inequality.
This is at least is the inequality.
And that's what you want to have.
I want it to be
Or total revenue.
total revenue to be bigger than this, right? Or equal to it, possibly. Equal is okay. I think I'll still be happy if it's just 345 million. But how do I set up, like, what does the linear inequality with the two variables look like?
800.
Okay, 800x plus 1,000y bigger than or equal to $345 million, right? Now, if we're going to do it this way, you need to tell me what x is and what y is before we do this, because x is not the iPhone X, right? So what is x? So we're all clear. X is the number of 8s, iPhone 8s sold. And then what is y? The number of X's sold. So there's different ways to make $345 million, right? You could sell nothing but iPhone 8s, right? Or you could sell nothing but iPhone X's. But you could also sell some combination of the two, couldn't you? And that's what we're about to figure out. All right, what do you suggest we do right now if we're going to try and solve this? What's the first step?
Try to plug in two numbers.
That would be testing, right? That would just be checking. But what's our, if this is a, sorry, I almost said system. If this is a linear inequality in two variables, I'm going to first turn it into an equation, right? That's what I'm going to do first. So first step, turn it into an equation. And now you have your choice of finding your X-intercepts or Y-intercepts. Or you can solve for Y. I kind of like the X and Y-intercepts. What do you think? X and Y-intercepts? Okay, let's go with the X-intercepts. This is step 2. I'm trying to graph this thing. Set Y to 0. I get 800X. I'm going to need somebody with a calculator. 345 million. Make sure you get your zeros in there. Divide through. Tell me what you get. What did you say? 400? 431,000. $250. Okay. Anyone else get that? Yes? Okay. And so our X-intercept will be 431,250, comma 0. That's kind of bad notation because there's 2 commas in there. So I'm going to take that comma out. All right, how about the y-intercept? Set x to 0, you just get 1,000, y equals 345 million. And what do you get there for y then? 345,000. So your y-intercept looks like this. 0, 345,000. When I put that number up there of 345 million, did you think like that's overkill? That's too much? No? You thought that was reasonable? Because does it seem to you like selling 431,000 iPhones is within reason? That seems like child's play. I think they can do that pretty easily, right? I don't know. Yeah, I would assume you're selling more than that, but I could be wrong. I've been wrong before. Yeah, it doesn't surprise me. All right, so now what? We've got the x and y intercepts now. Graph it, right? And am I going to use a solid or dashed line here? Solid, right? So now, how in the world are we going to graph this? This is going to be weird. I need to go out 431,250, right? On the x-axis. So start counting, right? 1, 2, 3, 4. No. We got to do something better than that, right? Count by what? Maybe like 10,000s? Let's count by 10,000s. No? Still not too much? Yeah. 100,000s? You want to do 100,000? Let's do 100,000s. So if this is 100,000, this is 200, 300, here's 400,000, right? Here's 500,000. And we are just going to eyeball this in here, okay? 431,000 would be, right, this is 400,000, 431,000 somewhere around here. Now, because my graph is not very good, I'm going to actually label that point so anybody looking at it will know what the value of it is. All right, so that point is going to be the point 431,500, 0. Now my y-intercept is 345,000. What? 250. Oops. Should have just looked to the right and I would have seen that. 250. Everything else right? Yeah. Okay, 345,000. So here's 100,000. Here's 200,000. Here's 300,000. Here's 400,000. So I don't know, somewhere around here? Yeah, not quite, just a little bit shy of the middle. And I'm going to label that point. That point is the point 0 and then 345,000. And I'm supposed to connect these with a solid line. Doing a terrible job here. Okay, now what? Test a point. What's a good point? 0, 0. So if I test 0, 0 in here, I hope it's obvious to you that 800 times 0 plus 1,000 times 0 is not going to be bigger than or equal to, right? It's not going to work. So I shade everything up, right? Or do I? That would be, I agree we need to shade up. We do need to shade this way, but not everything. Why? Because what? Well, I don't think Apple cares. As long as they've got the phones, they'll sell them. Apple cares. Do what? Say again? Million, and it's not, right? So when we tested that point, it's no good. So we're on the other side of that line. There's something else in here that we haven't discussed because this is a word problem and it's like a real world situation, there's something that we're, you can't what?
Have like a negative.
Yeah, you can't have a negative number of phones. Do you agree? They're not going to sell negative 100 iPhones. So let me try and I need to erase this so you can see the graph. I kind of ran out of room over there. Here's what we have right now. We have this, and I'm going to draw the line with a different color. We've basically got this as our answer. And what we're thinking we need to do is this. Yes? But that means that this point right here is part of our solution. And that would mean that we sell a certain number of, the X was what? iPhone 8s? And then our iPhone X's would have to be what? Negative. And that's no good, right? So what we need to do is take off, our answer has to also have this stipulation to it. The number of iPhone 8s we sell must be bigger than 0, and the number of iPhone X's we sell must be greater than or equal to 0.
So is this like a step 5?
No, this is because it's a word problem, you have to pay attention to it. It's not a step 5. To graph an inequality, to graph a linear inequality in two variables, we are done. But in terms of the word problem, this solution's not okay. So what does x being greater than or equal to mean? I want you all to see this. X greater than or equal to 0 means visually that we have to be to the right of this line, don't we? Anything over here works, right? So what I'm going to do now, again in a different color, to represent this situation, I'm going to draw a vertical line right on top of the y-axis, like this. And I'm going to draw arrows going out this way, like this. Do y'all see that? Wouldn't that mean x is bigger than 0? You all right? Yeah, okay. And then what about y being greater than or equal to 0? It's this, right? This line. And it's everything above that, right? I know this is starting to look like a mess, but you with me? Okay, back to this red one. I'm going to take out the shading part. I know it's everything up there, right? But I'm going to draw these little red arrows instead. So your answer is the region that all the arrows are pointing at. What do I mean by that? Could your answer include this triangle right here? No. Well, the green's pointed to it, right? The blue's pointed to it, but the red's not. So it can't be this triangle. It can't be down here, right? Because the red's pointed away. Can't be over here because the green and the blue are pointed away. Can't be over here because the red's pointed away. Can it be right here? No, the blue's pointed away. Now this may seem like yes, I see the region. You don't have to tell me that, like I see it. But as we move on, we're going to have like 6 different lines on the graph, and you're going to be like, where the hell's the region? You're just going to have to be looking for where the arrows are. That's what linear programming is. It's coming up 5.3. So the only region that includes all the arrows is this region right here. So notice it cuts off here, right? It goes up and then it cuts off here like this. Now it does extend forever, all right?
So you said it has to be shaded with all of the arrows?
Where all the arrows, yeah. See, because if I pick a point here, would you agree that both the red, the green, and the blue all point to this, right? The green's pointing to it, the red's pointing to it, the blue's pointing to it. But if I pick a point anywhere else, like here, that red's pointed away, and that's no good. You need all the arrows pointing towards it. So if some Apple executive wants to know how many iPhone 8s and iPhone 7s need to be sold to make at least $345 million, there are an infinite number of ways that can happen, right? There are an infinite number of ways. Any point within here will satisfy the inequality. All right. You all look thrilled. So just some ancillary things here before we move on to the next section. This first section was just about how to graph these. Okay, how to graph a single linear inequality. But I want to just be clear on something before I go forward. I'll give you a couple more examples. Graph x greater than or equal to 0 in 2D. In 2 dimensions, that's what I mean. What does x greater than or equal to 0 look like? We just did it, right? You have 2 dimensions here. It's a vertical line like this, and it's everything to the right. Right? What if I asked you to graph another example? X less than -3 in 2D again. So you'd start out like this, and then what? Vertical line, where? At -3. And what type of line? Dotted line. And shade everything where? If your x has to be smaller than -3, you have to be to the left. So you're going to be shading left here. You see that?
Wait, what did you just say? Elimination?
Because the inequality says that the x values have to be less than -3. So if this is -3, to the less means to the left. So like if I picked a point right here, this would be negative, let's say -5, 3. Okay, move out -5, go up 3. Do you agree that the x value of that -5 is less than 3? Yes. But that would have worked for -6, 3, -7, 3, -8, 3. Any of these points over here, any point I pick, the x is going to be less than -3. Okay, how about this one? Y greater than 0 in 2D. So this time I'm drawing what? Horizontal line. It's actually going to go through 0, or the y-axis, or the x-axis, like this. Oh, I messed up. It's supposed to be what? Dashed, right? So there, I'm going to make it dashed. There we go. It's a dashed line, like this, and I'm going to shade which way? My y values have to be bigger than 0. Up. So it's everything up from here. One more, and then we move on. Graph y is greater than or equal to -2. So what am I going to draw here? Vertical or horizontal line? Horizontal line. Where am I going to draw it through? -2 on the y-axis, right? And it's going to be solid or dashed? Solid. Okay. So I'm going to draw first my xy. Here comes my -2 right there. And I'm going to draw a solid line. And I'm going to shade everything where? Up. Above it. There we go. Questions? (5.2) Systems of linear inequalities. In two variables. Example. X plus y must be greater than or equal to 4. 3x minus y must be less than 10. You see a system. The brace means a system, right? You see linear inequality, linear inequality. So when we were solving systems of equations, when these were both equal signs, we used elimination or substitution, didn't we? That's the way we did it. We're still going to do that, but along with that, we actually have to graph both of these lines individually. We have to do the shading and all that stuff that we were just doing. We have to do that for each one of these. And we have to find where they hit each other. So there's a lot of work involved in this problem. Let's see if we can get through this. So first thing is, what do y'all want to find first? You want to find the intersection? You want to see where they hit each other? Try that?
We don't have to make it an equation on this one?
Oh yeah, we will. Yep. Yep. So let's find the intersection first. Find intersection. That's my first step here. I'll label it step 1. Did that not work? Is it dead? Yeah, you're good enough? Okay. So first thing I'm going to do is find their intersection. And to do that, I am going to switch it over to a good old-fashioned system of equations. So I'm just going to replace the inequalities with equals. And treat these things like they're lines. Okay? That's what I'm going to do. Now, how would you solve that? You would do elimination? Yeah, either way will work. If you're a fan of substitution, it's nice because you can solve this for x easily or y easily. And here you can solve for y easily. But if you're a fan of elimination, you just need to be able to add down and get these variables to cancel, right? And they already do. Do you all see that? Y and negative y, those already cancel. So if I were looking at this, I would do this with elimination. Just add straight down. So let's add down. What do we get?
4x.
If we add down, we get 4x equals 14. Then divide, you get x equals 14 over 4, which is really 7 over 2, which is really 3.5. Y'all okay with that? Using elimination to do this? What do you do once you have done the elimination? Or done that part? What do you do with that answer, 3.5? Plug in 3.5 in for x into either one of those, right? So I'm now going to take that answer, I'm going to plug it into the first one. Let's say x plus y is 4. I'm going to replace the x with 3.5. So 3.5 plus y equals 4. And subtract 3.5 from both sides and get just 0.5. So these two lines hit each other at the point 3.5, comma 0.5. Let's keep that in mind. I'm going to put that on my graph in just a little while. All right, so that's where these two things hit each other. Now, the second step is to work with just that one and do everything we just did in the previous examples. Turn it into an equation, right? Graph it, solid or dashed, shade above or below. Then move to this one. Same story. There's a lot of work, right? Okay, but that's what you have to do. All right, so in my next step, step 2, I guess we could say, is to shade regions for both inequalities. So that step, it sounds like, oh, just shade both regions or shade the regions for both inequalities. That sounds like a small step, but you understand the amount of work required for this step now. Okay, so let's do it. So let's start with that first one. What am I going to do? Start with this one. What am I going to do? Change it into an equals, right? So I've got x plus y equals 4. Now what? Get the x-intercepts and y-intercepts, or solve it for y and use the slope and the intercept. Your choice. Why don't I do the slope and intercept on this one? Let's solve for y here. Negative x plus 4? Yeah? And then what's the slope of this line? The slope m is negative 1, and then the y-intercept is 4, right? So let me go ahead and draw this now. This is my first graph. I'm going to probably wind up with another final graph. But for now, I'm just going to get an idea of what's going on. So I'm going to start at y-intercept of 4. I'm going to draw a dot. And then from there, to get to another point, what do? Use the slope, right? Negative 1? Rise over run. So you have to look at this as a fraction, don't you? So this would mean what? Down 1, right 1. Down 1, right 1. That's what this means. So I'm going to go down 1, right 1, and draw another dot. And then I'm going to connect the two, right? And when I connect them, I'm going to draw a what? Solid, because this was equal, right? So that's what I have here. Am I done? What now? Test a point, right? Test 0, 0. And where am I testing it? Into this, right? Does 0, 0 work? 0 plus 0, is that bigger than 4? No, so I'm going to be shading above. And so for this one, I'm going to draw my arrows like this. Notice I'm not shading. I kind of, now that, if you just have one equation, then shade. But now that we're going to have more than one, the arrows I think are easier to work with, but you got to make your own decisions on that. All right, I've got this one there, don't I? All right, let's do the other one now. For the other one, turn it into an equation again, right? 3x minus y equals 10. And I think again I'm gonna do the solving for y. So how did I solve for y there? What did I do?
Subtract 3x and then you divide it out by negative 1, which made it 3x positive.
You can do that, yes. That's not actually what I did in my mind. In my mind, I added y to both sides and subtracted 10. So basically, you would have the same exact effect. I moved the y to the right and moved the 10 over here, made it negative and made it positive. And so what's the slope of this line? 3, and that's 3 over 1, right? That's your slope. And then the y-intercept is negative 10. Okay? Now, I'm going to do this line in a different color. I'm going to do it in blue. Or let me do it in red. Okay, so I'm going to do this one in red. So I'm going to start out at